Hello and welcome to this series about building a batch platform on Kubernetes. I'm Mofi, a developer advocate at Google, working on Kubernetes and batch and AI platforms.
I'm Ali, and I'm a solutions architect at Google. I partner with Mofi in helping our customers build batch, high performance, and machine learning platforms on Google Cloud.
In the previous video, we took a look at a hypothetical company with 4 teams trying to run their batch workload on Kubernetes. In this video, we're going to take a look at how those teams can take advantage of queue monitoring to understand their workload better.
So, heading over to our Cloud Shell, you'll remember that we had a reference architecture GK cluster. It had one default pool with 6 nodes in 3 zones, and then it had 4 reserved VMs in a zone. Next, let's take a look at the namespaces that exist on this cluster. You'll see that we have a queue system namespace, meaning queue is already installed on this cluster. We also have 4 teams, team A, B, C, and D, that are sending their batch workloads to this batch platform. Next, let's take a look at the cluster queues that queue has been configured with. You'll notice that every team has 3 cluster queues: a high priority cluster queue, a low priority cluster queue, and a compact cluster queue. This provides a way for teams' jobs to compete with each other in terms of priority and when they were submitted before they compete with others that exist on the cluster for cluster resources. Finally, we have the resource flavors, which represents the resources that exist on this cluster. In this case, you'll see that there are 3 different kind of L4 GPU resources: on demand, reserved, and spot, based on the kind of provisioning that is happening underneath. And then we also see an A100 compact spot flavor that represents the ability to spin up A100 GPUs physically close to each other for low latency communication.
For monitoring our queue resources, we also have deployed Prometheus, Grafana, and Alert Manager in the monitoring namespace. To collect our queue metrics, we also have deployed the service monitor from Prometheus in the same namespace queue is deployed in. Queue is exposing all its metrics in the /metrics endpoint, which we are collecting from.
You can find Prometheus metrics that are exported by queue in the documentation linked in the description below. Let's head on over to Prometheus that's running in the cluster to see if we can find any queue metrics. As you can see, we're able to see all the queue metrics that are exported via queues controller. As a part of this monitoring suite, we also deployed Grafana, which will be able to visualize the metrics that are being collected in Prometheus.
Here, we have an example dashboard that showcases some of the key queue metrics. We can see that we have 10 nodes in this cluster. And for admission and admission latency or number of workload, we have no data yet because, again, it's a new cluster where we have not deployed any new workload. But we'll soon start sending workload and we'll be able to see how quickly our cluster and queue is able to take those workloads in. And we can also look at our scale up of our cluster as new nodes get deployed to handle the workload.
Let's go ahead and deploy some workloads to the cluster. We've seen the deployment scripts before, but as a quick overview, the script deploys one workload from each team, A, B, C, and D, until each team has 4 workloads deployed to the cluster. Let's go ahead and create the low priority workloads. As you can see, workloads from team A, B, C, and D are now being created onto the cluster.
As the low priority workloads are coming in, we can see that our dashboards are starting to get some data. Again, we just sent 16 workload and we have 16 active workload. We can see our load on our CPU and total number of nodes. Our autoscaler has not kicked off yet, but the moment it does, we're going to see the number of node go up from 10. To continue the load, let's send some high priority workload too.
So we'll head back to our Cloud Shell and create the high priority workloads. As those workloads are created, we should see the number of active workloads represented in Grafana going up. And as you can see, active workloads are going up. We have some numbers around admissions per second as well as admission latency. And you can see the active workloads per cluster queue being accurately represented as time goes on. You can also see pending workloads being reflected. These are workloads that have been submitted to the cluster, but have not been admitted by queue yet due to resources or quota not being available. You can also see under cluster nodes, CPU requested is at 93%. So that's pretty high. That's reflecting the requests that the workloads are making as compared to the resources that exist on the cluster. As additional nodes are deployed to the cluster, I expect that number to come down. You can see the total nodes increasing to 11 now as GKE adds additional virtual machines to field the incoming workloads. The CPU requested metric is predictably lower as new nodes get added to the cluster.
As we have additional nodes, our rate of admission has also gone up. That means Kubernetes now have the resources to be able to admit the workload that was previously pending. Using these metrics, we can not only visualize how our system is functioning, but we can also create alerts to create human intervention when necessary. For example, let's say we expect no more than 50 pending workload, then we can set an alert that says if our pending workload number ever goes beyond 50, send an email or a Slack message or a text message to one of our engineers so we can come and take a look to figure out if something is actually wrong or we just have a high demand of our resources.
In addition to the Grafana dashboard, we've also deployed an NVIDIA GPU monitoring dashboard in Cloud Monitoring. You can find the link for this dashboard in the video description below. Let's take a look at the features this dashboard offers. We can take a look at the number of GPUs by model that exist on a cluster. Here you can see that we have both NVIDIA L4 and NVIDIA A100 GPUs reflected on the cluster. The dashboard also provides a heat map of GPU utilization on the cluster. Understanding your workload's GPU utilization will allow you to more effectively choose the right kind of resource for your use case. You can also see utilization by individual GPU. This is useful to understand the performance and utilization of GPUs that process more than just one workload on your cluster.
In this video, we took a look at how to use Q metrics with open source tools like Prometheus and Grafana to understand how well our platform is performing. In the next video, we'll take a look at some more advanced job patterns and how to utilize them to build your batch platform.